My name's Eric Walski, and I'm a physics intern at Western Nevada College this summer. And today I'm going to talk about how we can make this slinky levitate. Here we have a slinky hung from a fixture in the ceiling, and this slinky is in a state that we call static equilibrium. And what static equilibrium means is that the tension in the spring that is holding it up is being canceled out perfectly by gravity that's pulling the system downward, resulting in no movement. Now, if you hold the spring up, it's loose and there's more gravitational potential energy. As you can see, when you drop it, gravity takes place. Or, on the other hand, if you pull down, there's no more gravity, there's no more gravitational potential energy to take place, but there's now spring potential energy, once again resulting in motion. And so, when it's moving like this, it's constantly exchanging gravitational potential energy for spring potential energy, back and forth until air resistance and a little bit of energy loss due to sound will bring the system back to static equilibrium. Alright, so here's our slinky in a state of static equilibrium. And now I'm just going to release it. And there we have a hovering slinky. Let's take a couple looks in slow motion. There are some physical principles here that are really interesting. Now, the reason that the bottom of the slinky hovers is a simple Newton's first law, is that objects at rest tend to stay at rest until acted upon by an outside force. Now, as long as the bottom of the slinky still has tension here, there's no outside force acting on it to bring it down. So, when the top of it's released, the slinky actually has a wave velocity, so it falls according to normal gravity. Everything you would expect gravity to do. But because the bottom is still in static equilibrium, the top has to come all the way down and make contact to make a shock wave to tell it to fall with gravity. Ergo, the reason we have a levitating slinky. Here, I performed the same experiment, but with a much longer slinky. This one spans about 2 stories when suspended. This slinky, however, is not a perfect spring because it's been deformed from its original shape. So, when the slinky falls, instead of being a perfect collapse, it kind of topples over to one side or the other, resulting in a sort of slinky train wreck.